So in this video I'm going to demonstrate array lists and hash maps. These are a couple of classes in the main Java code. So in the data types video we had a look at arrays. Here's an example of an array. I've got a my strings array. That's a string array and it has 3 string objects in it, 1, 2 and 3. And I can loop over the strings and print them out to the screen. So you probably expect this is going to say 1, 2, 3. Now what I may want to do some things to this this string array. So for example, I may want to add another object onto the end of it. So if I wanted to add 4 to this list, what I would need to do is I'd need to make a new string array, because this one has a dimension of 3. It has 3 objects in it. I need to make a new string array and copy this one across, or concatenate 2 string arrays or something. I'm not sure what the best way to do it is, but there's no real convenient way to copy to add a string onto the end. And you can imagine if you've got a list of objects, you're going to have this sort of thing in many different programming situations, and you're going to want to be able to add something to the end. Another thing you might want to do is you might want to take something out. So if I were to set this object, if I were to say my strings, that's an index of 1, remember, because we index from 0. My strings 1 equals null, maybe, to take it out. The array is still 3 long. We've just got null in the middle, 1, null, 3. But obviously the logical thing we'd want to do if we take 2 out is then to make the array shrink and be 2. So if you remember, we had like double and integer. These objects were wrappers for the primitive types. We've also got wrappers for arrays, and ArrayList is the simplest example, I think, of an array wrapper. Now the interface to ArrayList is a list, and there's a few different types of lists we can pick from in the Java. So we'll have a look at the Java doc in a minute, and you'll see that there's a stack where you put things on the stack and take them off the top, and there's a queue where you put things at the back of the queue and take them off the front. There's all different types, but the most simple type, I think, is the array list. So let's say we have a list, and now let's say my strings is a list object instead of an array. I'll just comment that out. We've defined the sort of lowest common denominator class here because we may want to implement a different class later, but we treat it as a list, but we'll say what it actually is here. Equals new array list. Now Java generics that we haven't yet covered is where we say what goes in that list here. So we can say it's a list of string. We do that in these less than and greater than type brackets. Equals new array list string. And my strings, now what I can do, what I couldn't do with the standard array, is I can add things. If I add 1 and 3, for example, it's going to behave just like an array, but now I can add things like that. So I've got 1 and 3. What I can also do is, obviously I can add 4 onto the end, but what I could also do is add 2, and then I can say, is it the first parameter? I can say the index that I want to add 2. So I can add 2 in the middle. 1, 2, 3. Maybe I can string first equals my strings. I can get the objects. Now an array list is the one that I usually use. An array list, things stay in the same order when you put them in. They stay in the same order. So this is saying get the thing at the first index. If we were doing this with an array, of course it would be in square brackets. So we'll get the first thing and system out print first. So I'll say that system out print first is first. So we're expecting this to say first is 1 and then 1, 2, 3. 1, 2, 3. Another thing I can do is I can remove. So let's remove the thing at element 0. So now we're going to say first is 1, 2, 3 because I've removed 1 for the list. So we can do all sorts of inserting things and removing things. Another thing we can do with string is we can do Collections.sort my strings. Now there's a reason why I'm making this video after the video on object oriented, so if this gets confusing then go back and watch the video on object oriented, because that's a kind of prerequisite for what I'm going to talk about now. So we're going to call Collections.sort strings, so that's a static method in the Java util collections package, and the method is sort, and it takes an array, it takes a list. I think it takes any sort of a list. So now it says first is 1, 3, 2. I'll forget about taking out that first one. So the sorted list of 1, 2, 3 is 1, 3, 2 because it sorted them in alphabetical order. The most logical way to sort a string would be in alphabetical order. So the way this works is string implements a interface called comparable. That interface has a method which is compare to, and the string has a compare to method where it can compare itself to another string. Now let's in the object oriented method I did classes about animals, so I'm going to make a new animal class. Class animal, and our animal class is going to have a name. This is going to be the species name, and it's going to have a weight in kilograms. I'm going to give this a constructor, and I'm going to give it a toString method. All of these methods, the constructor, the toString, and the getters and setters and things like this, we can generate automatically in Eclipse because it's just standard programming. So if we generate toString, we can say what fields we want in this toString. So animal, I picked both of the fields, name and weight. So now when we print this animal in a system out print line, we'll get name equals whatever it is and weight equals whatever. Now I'm going to change my strings. Another useful Eclipse feature is right clicking on things and saying refactor. We can move things and we can name things, and we can also do loads of other things which I don't use very often, but I often use rename, where we can rename this object. But the thing is, as we rename it everywhere else that it's referenced. So that's really useful because that includes renaming it in other files. So if you've got an object and you've changed your mind about what that object should be called, then you can rename it like that. Right, so my animals. Now my animals list is going to be a collection of our new animal objects. And I've got an error now because I'm trying to add 1, 2 and 3 to our collection of animals. just take out that. I'm just going to add three or four simple animals. Animal cow, and I'm going to give that a weight of 1,000 kilograms. Do cows weigh a ton? I don't know. And I'll add an animal, a dog. And our dog weighs 4 kilograms, 5 kilograms. Yeah, this is just ridiculous, but it's just to demonstrate. And I'll add a new animal, a pig, and the pig can weigh 600 kilograms. Now I've got an error on Collections.sort, so I can't sort the animals. It's saying that the method sort list of type in the collections is not applicable for the arguments animal. That's a bit of a confusing way of saying that our animals can't be sorted. So I'll comment that out for now, and for animal, that says my string, which is not an error, but I really want it to be my animal. In my animals, system output my animal. So animal cow weight 1,000, dog weight 4, pig weight 600. Now if I want to be able to sort my animals in the weight order, what I can do is I can say I can implement the comparable interface. So implements comparable. Now I've got an error here. It says add unimplemented methods, because if you remember, interface defines methods that we have to define in order to fulfill that interface. So now an animal implements comparable, it needs to add the unimplemented method compare to, and we want to compare it to another animal, and I think I can put in generics that it can be compared to another animal. And here I always forget which way round this goes, but we want to compare the weight and we want to return an int. Really we want to return a positive int if it's one way round, and a negative int if it's another way round, and 0 if it's the same. So what I mean is, if weight is greater than the, I always say other dot weight, return 1. If weight is less than other dot weight, return -1. Otherwise return 0. Now I can do collections.sort my animals. That was a Control Shift and O. When you need to import something in Eclipse, do Control Shift and O and it will automatically find it for you. Importing, if you're not clear, is when an object is not in the package. If you're referring to a class which is outside of the package that the class that you're referring to it in is, then you need to import it from the other packages, and these Java util are just standard bits of Java that we're importing. Okay, so now we can sort our animals because it implements comparable. So the animal's name is dog weight 4, pig weight 600, cow weight 1000. So we've said we compare animals by weight. Now there's also a way that you can pass a custom comparator class, so you can sort by different things, but this is the most straightforward way of sorting animals. Right, so that's all I'm going to cover on ArrayList, but it would be worth having a look at some the Java doc, so if I just look at the Java doc for ArrayList, we can see that it's extends abstract collection followed by abstract list. Then we have ArrayList. These are the interfaces that it references, that it implements, and here are some subclasses. So these are going to be even more specialized versions of a list. And we can look at all the methods that we can do. So we can clone the list, we can clear the list, we can add things from another collection. We can, this is the one that we use where we added at an index. We can just add at the end, and we've got a whole load of methods that we can use. Size is an important one, which will return the size of the list. We can set an item at an index to be a new element. So there's all sorts of things we can do with ArrayList, and I use them all the time, and you probably will too. So that's what I wanted to show you in ArrayList. Next, I'm going to make a sort of database collection of my animals, but I want to index them by a reference number. So I want to add an animal, but with a unique ID, and I want to store it in a list so that I can fetch that animal out of the list. And this is what a hash map is good for. So if I just get rid of the I'll get rid of the sort for now. A hash map, the interface is map, so we should always treat things as the if it's an interface and we're treating it as that interface, we should define it as that interface. So I'm going to say map, I'm going to say string comma animal. So a map has two elements to it, the key and the element itself, and we'll make it a hash map. I always forget if that's a capital M or not. I think it's not actually, but I'll do Control Shift and O, see if we can import it. Yeah, it is. Right. Okay, now I can add my animal. Let's say we've got to make it a string, so we'll call this A1 for animal 1, and the method in HashMap is put. So put A1 animal 1, my animals put A2 animal 2, and put A3 animal 3. So now I've put our three animals into a map, and they have a sort of key as a name. Now hash maps are really efficient ways of storing things, so what I can rather retrieving things. So if I say my system out print 9 my animals get, and then I give it the key. So if I say A2, in the most efficient way possible by using a hash function, it's going to get the animal stored at A2. So this should system out print line the dog with a weight 4, and there you go. And we can also, there's other methods in HashMap. We'll have a look at the Java doc now, and then I'll demonstrate some of it. So Java doc. HashMap. So So we can clear it, we can check to see if a key is present, we can check to see if a value, so that there's the key and the value, we can check if there's a value present, we can get an object from the key. Key set, this one I'll demonstrate. So this is where we get the key as a set of whatever type the key is. This put we've demonstrated already. We can merge with I don't know, I've never used that, but we can remove an object like we did with HashMap. But you know, the main difference is that we are storing things with another thing as a key. Values is another good one, which gives us a collection of the values, and size like in ArrayList. So what I'm going to do is I'm going to get the keys, and we can iterate over a key by saying, for we know the key is a string key in my animals key set, and then we can system out print line key. So that will get us the keys, so we can see which keys we got, A1, A2 and A3. Values will do a similar thing, so animal in my animals values, and we can system out print line animal, and that gets our animals. So we've looped through the keys, looped through the animals. So that's what I wanted to demonstrate. A couple of collections classes. So we've looked at ArrayList and we've looked at HashMap. Now the point of me showing you this is partly because I use ArrayList and HashMap all the time. They're very useful. You can imagine that when you have data, you're going to want to store it in a. Very often, you're going to store it in a list. I usually make simulation programs, train simulation programs, and I have a list of trains. I have a list of bits of train track. I have a list of signals. I have a list of stations. All these things, and I store them in maps in a database object, and it's just the obvious way of storing things. Another thing I wanted to demonstrate at this stage in this tutorial series is that these sorts of things like lists that you insert things into, and that you can imagine that you're not the first programmer that's ever wanted to do this, and it's such a generic function that it's included with Java itself. So the libraries in Java util, and as well as loads of other libraries in Java, for things that everybody wants to do, like operate files, or string is an example of one of the Java classes. But these things are included within Java. So if you want to do something and you think you're not the first person that's ever wanted to do this, so put things in a list or something like that, then it's always worth Googling and seeing if there's some example code that uses the Java libraries. And the more you become familiar with Java, you'll become familiar with these objects that you can use to build your programs. Okay, so that's it for now. Thanks for watching.